Hi everyone, in this video we will be covering the concept of strength, concentration and basicity of acids. Before we start, you probably have already learned the definition of acids, so let's take a minute to recall what is the definition of an acid. So an acid is a substance that dissociates in water to produce hydrogen ions. Let's turn our attention to the simulation over here. One example of an acid that we have learned is hydrochloric acid. So when I place hydrochloric acid in water, notice that it undergoes dissociation, where you break it up to form your H plus and Cl minus ions. Recall in the earlier lesson, we mentioned that acidic properties are determined by H plus ions, whereas electrical conductivity is determined by the presence of free-moving ions or your mobile ions. If I were to present you with a simple mind map, these three factors, they will affect the concentration of your H plus ions, which will affect your pH, which will affect the reaction rate. What does it mean by reaction rate? Will be how fast the acid reacts with, let's say, a metal, a carbonate, or a base. Your concentration of mobile ions will affect the electrical conductivity. So the higher the concentration of mobile ions, the greater the electrical conductivity of the acid solution. Okay, so we'll explore how each of these three factors will affect these three outcomes. Let's take a look at the first factor, which is the strength of an acid. The strength of an acid is defined as the extent of dissociation of an acid when it's dissolved in water. We know that acids undergo this process of dissociation, so if we were to write the equation for dissociation for HCl, it looks something like this. So a strong acid is one that dissociates completely in water to give a high concentration of H plus ions. Basically what that means is if I have 10 HCl molecules, I'll get 10 H plus ions and 10 Cl minus ions. So every single molecule will be broken up into your H plus and Cl minus. Sometimes we'll represent acids with the general formula HA, and the HA basically means your H plus and your anion denoted by A minus, something like this. Okay, so if we are talking about hydrochloric acid, then your A minus is your Cl minus ion. If we are talking about nitric acid, then your A minus is your NO3 minus ion. A weak acid, on the other hand, undergoes partial dissociation. One example would be ethanoic acid, which is given by the formula CH3COOH. So if I were to have 10 ethanoic acid molecules, perhaps only a fraction of them will undergo dissociation at any one point of time. We can see this a little bit clearer through the simulation, and you can have a go at it as well to try to play around with some of these parameters. So over here, in this diagram, I have a weak acid because you notice that only a small fraction of your HA molecules, which are in gray, have been dissociated to form the blue color A minus and the small little one, the H plus. Most of them remain as the molecules. Okay, so this is an example of a weak acid. Only a fraction of them undergo dissociation. I'm going to pull the slider a little bit more to the right and notice that as I increase the strength of the acid, a greater fraction of the acids undergo dissociation. Okay, so a stronger acid is one that undergo a greater extent of dissociation. And if we were to treat it as a strong acid, we say it undergoes complete dissociation. Means every molecule will dissociate to form H plus and your A minus ions. Okay, so you can already see how increasing the strength or changing the strength has an impact on the concentration of H plus ions and your free moving ions. Now I'm going to do the same. I'm going to put the pH probe in. Okay, notice as I push the slider to the right, the pH actually goes down as the concentration of H plus will increase. Alright, let's do another experiment. This time round, let's take a look at the light bulb. The light bulb lights up because there are free moving ions. But as I make the acid stronger, the light bulb becomes brighter and brighter because the concentration of your mobile ions increases. So as the concentration of your H plus ions increases, the rate of reaction will be faster and faster because you have higher frequency of collisions between your reacting particles. Okay, so a stronger acid has a faster reaction. Now take note that, when the H plus ions are reacted away, more of the acid molecules can undergo dissociation. So eventually, all the acid will be completely reacted. Okay, and we can try to simplify it a little bit by looking at this diagram. So for example, if I have a piece of metal here, let's say magnesium, so your H plus and your magnesium metal can react together because acid react with metal to form salt and hydrogen. So once this H plus ion has reacted away, more of these acid molecules will break up to form H plus and your anion. And then this H plus will then react with the metal again. More of it will undergo dissociation to form H plus and A minus. This one will then react again until eventually all the molecules undergo dissociation. So a weak acid means that at any one point of time, a fraction of the molecules will be dissociated, but at the end of the reaction, all the H plus will be completely reacted away. Okay, so this is something that I think many students find it difficult to understand. Okay, one analogy that you can think of is, let's say I have $100 in my wallet. Okay, so a strong acid means undergo complete dissociation, all the dollar bills come out, I spend everything all at once, so I spend it very, very quickly. All right. A weak acid, on the other hand, same thing. I start off with $100 in my wallet. Okay, every day I take out $10. Once I spend the $10, I withdraw another $10. I withdraw another $10. Eventually, I still use up all my money. So that's the difference between a strong acid and weak acid, which is the extent of dissociation. I would like to draw your attention to the equation here. A strong acid is denoted by a single-headed arrow, which means that it goes in one direction. A weak acid dissociation equation is denoted by this double-headed arrow. When ethanoic acid undergoes dissociation, you actually form the ethanoate ion. Okay, we will learn about this in the chapter of organic chemistry, but here's just one example for you to be familiar with first. You may notice that the ethanoic acid molecule has so many hydrogens, right? But only one of them undergo dissociation. All right. So if you remember your chemical bonding, we can represent molecules using a structural formula. Okay, so the ethanoic acid molecule actually looks something like this. All right, where there are covalent bonds between the carbon and hydrogen atoms. So when it undergoes dissociation, only this covalent bond breaks to give you your H plus, and the rest of it as the ethanoate ion. Okay, so the other three H, right, do not dissociate. All right, this is something for you to take note. So let's summarize the two key points here. Number one, greater concentration of mobile ions, greater conductivity. Number two, greater concentration of H plus ions, you have a faster rate of reaction. Now here's a question for you to think about. Design an experiment to show that sulfuric acid is a strong acid, but ethanoic acid is a weak acid. So when we design an experiment, we think of variables. I think you learned about some of this in the lower side. We have your independent variable. So what you change will be the type of acid. Your dependent variable, so a weak acid will probably react slower, and a strong acid will react faster. So what we can do is we can carry out an acid plus metal reaction where hydrogen gas is being given off. So to each sample of the acid, right, we put in magnesium ribbon and we collect the gas. So we want to time and see which one will produce the hydrogen gas in the shortest amount of time. Okay, so time taken to collect a fixed volume of gas. And other things you want to keep constant will be the temperature and the conditions, right? Your concentration of acid and the volume of acid. All right, so this is just one way. Okay, there are other ways that you can think of, but this is just to get you started thinking about this problem. All right, when we go into practical skills, we'll cover more of such kind of questions, which are known as planning type of questions. Now let's look at the second factor that affects the acid properties. It's the concentration of acid. So concentration is defined as the number of particles per unit volume. Over here, if you look at the right-hand side of the simulation, I have a 0.010 mole per dm cube concentration of acid. So if I were to decrease the concentration, there are now fewer particles per unit volume. If I were to increase the concentration, it gets more and more crowded, okay, more and more concentrated. So going back to our parameters again, if we were to look at our pH, if I were to increase the concentration, I will get a higher concentration of H+, the pH actually goes down. Okay, and that makes sense. And likewise, if we were to look at our light bulb, right? If I have a low concentration of acid, the light bulb will be dimmer because the concentration of mobile ions is lower. If I have a high concentration of acid, the light bulb will be brighter because there's a higher concentration of mobile ions. So one thing to point out is that the strength of an acid is not affected by the concentration. Okay, a strong acid will undergo complete dissociation whether or not it is diluted or concentrated. We can take a look at this as another example. This is low concentration. High concentration basically means I'm just going to put a lot of it inside. Okay, so this is of a higher concentration. The last factor is called basicity. The basicity of an acid is the maximum number of H+ ions per molecule of acid that dissociates completely in water. So what does that mean if we look at the simulation? HCl is known as a monobasic acid. That means one molecule of HCl gives you one H+ and one Cl-. Likewise, nitric acid is also a monobasic acid because every molecule of nitric acid gives you just one H+ ion. In comparison, sulfuric acid is a dibasic acid because when it undergoes dissociation, you get two H+ ions per molecule of acid. So for the same concentration of acid, sulfuric acid gives you twice the concentration of H+. So just by looking at the diagrams over here, which acid will make a light bulb glow brighter? Which acid will have a better electrical conductivity? I think it's quite obvious that sulfuric acid will be a better conductor because greater concentration of mobile ions. Which acid reacts faster? Of course, it will be sulfuric acid as well because for the same concentration again, you have so many more H+ ions, actually twice the number of H+ ions that can react. Okay, so each molecule of acid produces two H+ on complete dissociation. So that kind of sums up these three factors: strength, concentration, and basicity. The strength is the extent of dissociation. The concentration is the number of particles per unit volume. And the basicity is the maximum number of H+ produced when one molecule of acid undergoes complete dissociation. We have learned 4 different acids. Let me summarize them for you on the right. HCl, HNO3, H2SO4, and ethanoic acid CH3COOH. Okay, so these are strong and ethanoic acid is a weak acid. Okay, next, hydrochloric acid, nitric acid, and ethanoic acid are monobasic acid because they only produce one H+ ion on complete dissociation, whereas sulfuric acid is a dibasic acid. I hope now you have a better idea of these 3 factors. So that's all for this video. I'll see you all in class.